My dear students, in this video also I am going to solve some problems in partial derivatives. Find the partial derivatives of the function. If the function is given by v of x, y, z equal to x cube plus y cube plus z cube plus 3xyz. X cube plus y cube plus z cube plus 3xyz. It is a function of v in the variables x, y and z. Then show that dou square v by dou y dou z equal to dou square v by dou y dou z equal to dou square v by dou z dou y. We have to prove this result. It is the ninth problem in the exercise 8.4. In the exercise 8.4, this problem is the ninth problem. So v is given. What is dou v by dou y we want? We need not dou v by dou x because it is given as dou square v by dou y dou z and dou square v by dou z dou y only you have to prove. Therefore, you need not find dou v by dou x. We want dou v by dou y only. X cube is derivative with respect to y0. Y cube is 3y square. Z cube is 0 plus 3x z are constant. So derivative of y is 1. Therefore, this is dou v by dou y. Now, dou square v by dou y dou z. For that, we want to find dou v by dou z. Here also x and y are constant. Z cube is 3z square. We are differentiating with respect to z partially. Plus 3xy are constant. Derivative of z is 1. This is dou v by dou z. Next, we have to find out dou square v by dou y dou z. This is nothing but dou by dou y of dou v by dou z. Dou square v by dou y dou z is nothing but dou by dou y of dou v by dou z. That is dou by dou y of, you know dou v by dou z. This is dou v by dou z. That is 3z square plus 3xy. Here we are differentiating with respect to y. Therefore, 3 and z square are constant. This term becomes 0. Derivative of y is 1 with respect to y. Therefore, you get only 3x. So, dou square v by dou y dou z is 3x. Similarly, right hand side, dou square v by dou z dou y. This is nothing but dou by dou z of dou v by dou y. That is dou by dou z of dou v by dou y, you have 3y square plus 3xz. 3y square plus 3xz. Here also we are differentiating with respect to z, therefore 3 and y square are constant. Or differentiating with respect to z, this first term is 0 and 3 and the derivative of z is 1. If 3x is constant, you can take 3x. Constant derivative of z is 1. Therefore, this is also 3x. So, dou square v by dou y dou z equal to dou square v by dou. Therefore, we have proved dou square v by dou y dou z equal to dou square v by dou z dou y. We proved both are equal to 3x. So that's all about this problem. Next, one more problem in the exercise. We'll see. partial derivatives are ordinary differentiation. The results of the ordinary differentiation you have to remember. Then only this partial derivative is very easier to. Okay. Next problem. In the exercise, there is a problem number 6. The problem is W of x, y, z. W of x, y, z equal to 1 by root of x square plus y square plus z square. W of x, y, z is 1 by root of x square plus y square plus z square, where x, y, z are not equal to 0. They are not, they should not be 0. X, y, z are not equal to 0. Then only the function exists. That is a condition. And this W of x, y, z, you can express as this is x square plus y square plus z square power minus of the root of denominator. Root square root is, if you bring it to the numerator, it becomes power minus of, because this is root is x square plus y square power of. If you bring it to the numerator, it's minus of. Now differentiating dou w by, now what is that? The problem is to show that this problem, they ask you to show that dou square w by dou x square plus dou square w by dou y square plus dou square w by dou z square equal to 0. They ask you to prove this. For that, dou w by dou x is equal to, on differentiating this becomes minus of into x square plus y square plus z square power minus of minus 1 is minus of minus 1 is minus 3 by 2. X square rule, x power n is n into x power n minus 1. Minus of into x square plus y square plus z square power minus of minus 1 is minus 3 by 2 into derivative of x with respect to x is x square derivative is 2x. Y and z are constants. Therefore, minus 2 cancel, you bring that x into the front, you bring that x to the first term as x into x square plus y square plus z square. Minus 2 cancel, minus x into x square plus y square plus z square power minus 3 by 2. This is dou w by dou x. Again, dou w by, again with respect to x, you can differentiate dou square w by dou x square is, you have to differentiate dou w by dou x again with respect to x. For that, you keep this minus x as constant and minus 3 by 2 into x square plus y square plus z square. I am keeping minus x as a constant term, uv rule. Keeping u constant, derivative of v is minus 3 by 2 into x square plus y square plus z square power minus 3 by 2 minus 1 is minus 5 by 2. Minus x into this term, derivative of this is minus 3 by 2 into x square plus y square plus z square power minus 3 by 2 minus 1 is minus 5 by 2 into derivative of x square with respect to x is 2x plus, now you keep this second v, x square plus y square plus z square power minus 3 by 2 as it is, derivative of minus x is minus 1. Therefore, this is equal to minus into minus plus x, minus into minus plus 2 cancel. These 2 and these 2 get cancelled, minus into minus plus x into x square. Okay, you take x square plus y square plus z square, x square plus y square plus z square power minus 3 by 2 in both the terms. You can take it as a common term. Here also you can x square plus y square plus z square power minus 5 by 2, you can take minus 3 by 2 as a common term. And here also I get x square plus y square plus z square power minus 3 by 2. Taking this term as a common term, in both the cases it becomes minus into minus plus x into 3x square. Okay, and one more term is x square plus y square plus z square power minus 1. If I take minus 3 by 2 from minus 5 by 2 outside, I get minus 3 by 2 minus 1 is minus 5 by 2. Therefore, you will get only power minus 1. Plus, here you can take this entire term as a common term, you will get only minus 1. This is dou square W by dou x square. Similarly, dou square W by dou y square is also the same thing repeated, x square plus y square plus z square power minus 3 by 2 into, instead of x, you will get 3y square into x square plus y square plus z square by power minus 1. Okay, this is power minus 1 and that minus 1. The same thing is repeated because it's a cyclic function. Therefore, again dou square W by dou z square is again x square plus y square plus z square power minus 3 by 2 into 3z square into x square plus y square plus z square power minus 1 the whole minus 1. Okay. Dou square W by dou x square, dou square W by dou x square, dou square W by dou z square. Adding these three in all the three terms, you will get x square plus y square plus z square power minus 3 by 2 as a common term. Okay, you see. We have to prove that dou square W by dou x square, dou square W by dou x square plus dou square W by dou x square is equal to 0. We have to prove that step. We will see one by one. Next, we want all the three. You have to add these first 1, 2, 3. These three equations you have to add. This dou square W by dou x square plus dou square W by dou y square plus dou square W by dou z square equal to, adding 1, 2 and 3, x square plus y square plus z square power minus 3 by 2 as a common sum. We will take x square plus y square plus z square power minus 3 by 2. I can take the term as common, and also x square plus y square plus z square power minus 1 is common here. Here you will get, this is x square plus y square plus z square by power minus 1 into 3x square plus 3y square plus 3z square. 3x square plus 3y square plus 3 z square. 3x square plus 3y square plus 3 z square. Minus 1, minus 1, minus 1. Adding minus all this 3, minus 3. Okay. This is again nothing but x square plus y square plus z square power minus 3 by 2 into. This term becomes the denominator of this. That is 3 into x square plus y square plus z square. If I take 3 common, I will get 3 into x square plus z square plus z square divided by power minus 1 becomes x square plus y square plus z square. Power minus 1, if we bring it to the denominator, minus 3. See, these two terms cancel. Minus 3, 3 minus 3, 0. 0 and everything is 0. That's all the result. See, this is equal to x square plus y square plus z square power minus 3 by 2 into 3 minus 3. 3 minus 3 is 0. 0 into the plot, everything is 0. Answer is 0. Proved. And the result, dou square W by dou x square plus dou square W by dou y square plus dou square W by dou z square is 0. We proved the result. So it's an important problem. Next idea, chain rule. under partial differentiation, we have to use chain rule. We will see chain rule in partial differentiation. Our next idea. That means function of function rule. Chain rule is nothing but function of function rule. Function of function rule in partial differentiation. Function of function rule. Function of function rule. In this case, u is a function of two variables. Same. U is a function of two variables x and y, where x and y are functions of t. X and y are functions of t, where yu is a function of x. Here, this is function of a function. U is a function of x and x and y are functions of t, single variable t. Okay, in this case, they ask you to find out du by dt equal to, the result is dou u by dou x into dx by dt, because x is a function of t, plus dou u by dou y into dy by dt. Dou u by du by dt, you want dou u by dou x into dx by dt, plus dou u by dou y into dy by dt. This is the rule to find out function of a function under partial differentiation. For that, we will consider this problem. In exercise 8.6, there is one problem. U is a function of two variables x and y, namely x square y plus 3xy power 4. X square y and plus 3xy power 4, where x equal to e power t and y equal to sin t, where x and y are functions of t. X equal to e power t, y equal to sin t. Okay? We have to, they ask you to find problem is find du by dt at t equal to 0. That is the problem. We will see one by one. What is dou u by dou x? Dou u by dou x with respect to x, y is constant, x derivative is 2x, x square derivative is 2x into y, plus 3xy power 4, 3y power 4 constant, derivative of x is 1, therefore 3y power 4. This is dou u by dou x. What is dx by dt? X is a single variable t, so total differentiation of dx by dt equal to e power t, derivative is e power t. So you know dou u by dou x and dx by dt. Dou u by dou x and dx by dt. Similarly, dou u by dou y. With respect to y, you differentiate y, 1 into x square is x square, because x square is constant, derivative of y is 1. Here also y for 4 is a function, 3 and x are constant, 3x into y power 4 derivative, 4y cube. So 4 into 3, 12 xy cube. 4 into 3, 12 x y cube. This is dou u by dou y. X square, derivative of y is 1. 1 and x square. This is 4 into 3, 12 xy cube. What is dy by dt? Derivative of sin t, you know cos t. We want du by dt. Du by dt equal to dou u by dou x. 2xy plus 3y power 4. This is dou u by dou x. into dx by dt is equal to t plus dou u by dou y x square plus 12xy cube into dy by dt cost. Okay. Here you replace the x and y using e power t and sin t. This is dou by dou t, du by dt is dou by dou x into dy by dx plus dou by dou y into dy by dt. This expression we have determined. Now you replace what is 2 into x is e power t, y is sin t, plus 3 into y power 4 is sin power 4t into e power t, plus similarly x square is e power t square is e power 2t, plus 12 into x is e power t, y is sin t sin cube t, y cube is sin cube t into cos t. Okay, this is after substituting x and y. We have du by dt in terms of t, and you find out du by dt at t equal to 0. So our problem is we have to find out du by dt at t equal to 0. Come on. What is the value of du by dt at t equal to 0? So du by dt at t equal to 0 equal to 2 e power sin 0, 2 e power 0, 2 e power 0 is 1 into sin 0, sin 0 is 0. Therefore the entire term is 0. This is sin 0 is 0, therefore 3 into 0 is 0. Into e power t is e power 0. Plus again e power 2t, e power 0, t equal to 0, plus 12 into sin cube t is 0, 0 into everything is 0, into cos 0, cos t is cos 0 is 1. Here 2 into e power 0 into everything is sin 0 0, and this is 0. Yes, it is 0, yeah. 0 plus 0, 0, 0 into e power 0, 1, this is 0. Okay, everything is 0. This is 0 and this is 0, e power 0 is 1. Plus here e power 0 is 1, this is 0, into cos 0 is 1. So your answer is 1 into 0 0 plus 1 into 1 is 1. So answer is 1. So du by dt at t equal to 0 is 1. This is our answer. Okay. That's all about the problem. 0 plus 1 is 1. Therefore, du by dt at t equal to 0 is 1. See, this is a method of finding du by dt at t equal to 0 using function of function in partial derivatives. Okay. After finding du by dt, you replace x and y in terms of t and then after that you will substitute t equal to 0. Okay. And then you have to substitute t equal to 0. We will get the result. Okay. In the same way, suppose u is a function of x and y and x and y are functions of 2 or more variables. In this case, what is the value of finding partial derivative? So both x and y are functions of 2 variables. So far we have seen x and y are functions of a single variable t. U is a function of x, y and x and y are functions of t only. But in this case, we will see v is a function of x, y, 2 variables, that is equal to e power x sin y, where x is s into t square and y is x square into t. X and y are two variable functions, st square and s square into t, where s and y are functions of two variables. We have to find out dou v by dou s. Find dou v by dou s and dou v by dou t at s equal to t equal to 1. That's our problem. In this case, v is a function of two variable, and that variable is again a function of two variables. Therefore, we want dou v by dou s equal to dou v by dou x into dou x by dou s plus dou v by dou y into dou y by dou s. This is dou v by dou s. Instead of dx by ds, we have to dou by dou y, because x and y is also functions of two variables. In this case, dou v by dou s is dou v by dou x into dou x by dou s. What is dou v by dou x? Dou v by dou x, e power x. This derivative of e power x is e power x sin y constant. This is dou v by dou x. What is dou x by dou s? Dou x by dou s. Derivative of s is 1. 1 into t square is t square. Because t square is constant, so only you will get t square. The derivative of this is 1 plus dou v by dou y. E power x constant. Derivative of sin y is cos y. E power x derivative is e power x sin y constant. Dou x by dou s is s. S derivative of s is 1. 1 into t square t square. Plus dou v by dou y. E power x constant. Sin y derivative is cos y into dou y by dou s. Here s square derivative, t is constant, s square is derivative of s is 2s. That's all. That is e power x. I can take common term. I will get t square into sin y, t square into sin y plus e power x again 2s into cos y. This is dou v by dou x, dou v by dou s. We want and replace x and y in term. What is the function given? E power x is st square, t square into sin y is s square t plus 2s into cos y is again x square t. Now you replace dou v by dou s in terms of s equal to t equal to 1. S and t are 1. So s equal to 1, t equal to 1, e power 1 is e into t is 1. 1 into s is 1, 1 into t is 1, sin 1, 1 into sin 1. Plus 2 into 1, 2. Cos 1 into 1, 1, therefore cos 1. So this is dou v by dou s at s and t equal to 1 is e into sin 1 plus 2 cos 1. That's all about dou v by dou s. Similarly, you have to find out dou v by dou t. So in the same manner, you have to find out dou v by dou t. After that, you replace s and t in terms of 1. Okay? What is dou v by dou t? Dou v by dou t equal to dou v by dou x into dou x by dou t plus dou v by dou y into dou y by dou t. Okay. What is dou v by dou x? Dou v by dou x, here the same dou v by dou x is the same, e power x into sin y. But dou x by dou t, dou x by dou t is s constant, t square is 2t to 2st. This is 2st plus dou v by dou y. Dou v by dou y was e power x cos y. E power x cos y, dou v by dou t. with respect to t, you have to differentiate y with respect to t, derivative of t is 1, 1 into s square is s square. So this is dou v by dou t. I am rewriting here dou v by dou t equal to dou v by dou x into dou x by dou t plus dou v by dou y into dou v by dou t. Dou v by dou x is e power sin y into 2st plus dou v by dou y is e power cos y into dv by dt is derivative of t into 1 s square. Okay, that is dou v by dou t is, that is dou v by dou t is, here also you can take e power common, you will get e power common, you will get 2st sin y, 2st sin y plus s square cos y. Now you replace x by st square, and here 2 into s t into sin of y, y is s square t plus s square into cos of y is s square t. Now you find out dou v by dou t, dou v by dou t in terms of s equal to t equal to 1. E power 1, s is 1, t is 1, e power 1 e, here 2, 1 into 1, therefore 2 into sin 1 into 1 into 1, 1 sin 1 plus here what is that, s square is 1, 1 into cos 1, therefore you will get cos 1. So e into 2 sin 1 plus cos 1 is dou v by dou t at s equal to t equal to 1. That's all about the result. See, function of a function rule. If a function has two variables and that variable again a function of two variables, in this case, this is the result. So I explained both the cases. You listen the problems sincerely and you will try to solve few more problems in your textbook. We will see in the next video. Thank you.